there, I'm Sam, and I work at the Woolbach Library, which is the library for the Harvard-Smithsonian Center for Astrophysics. Today I'll be talking about Star Notes, which is a citizen science project that we launched last year on the Zooniverse platform. I'll also be talking about Project PHaEDRA, which is the initiative behind Star Notes. So this presentation will kind of serve as an introduction to both of those things. So first, I'm going to give a little bit of background and history about, these two projects. So the Harvard-Smithsonian Center for Astrophysics was originally founded as the Harvard College Observatory in Cambridge, Massachusetts. William Cranch Bond was appointed as Harvard's first astronomical observer when the observatory was founded in 1839. This is an image of the Great Refractor Telescope at the observatory. The Great Refractor was put into use in 1847, and at the time it was considered the most powerful telescope in the US. So in the 1880s, the observatory director, Edward Pickering, started hiring women to work as computers. And at the time, a computer was a job title, much different from our computers now. Computers were people who did computations by hand. And so Pickering hired these women to study and take care of the glass plate photograph collection at the observatory. These women would, in general, be referred to as the Harvard computers. Many of these women had earned degrees in astronomy from, local women's colleges such as Radcliffe. And however, the observatory only paid the female computers 25 cents an hour, which in today's money is $6.85 an hour. In a lot of ways, referring to these women as computers kind of diminished their work as women, and the observatory could also save a bit of money by hiring women, which was a bit of the incentive there. So here you can see an image of Edward Pickering with a group of the Harvard computers. So in this photo, you'll see two computers working together. The woman on the right is Williamina Fleming. Computers would often work in pairs, where one would look at a glass plate photograph and read off observations to another computer who would be taking notes in a notebook. And so I'll be explaining what a glass plate photograph is in a bit and how the computers use them. And so before I explain the glass plates, I just wanted to spend a little bit of time introducing Henrietta Swan Levitt and Williamina Fleming, who both worked as computers at the observatory. Williamina Fleming was born in Scotland and actually worked as a maid for Edward Pickering before she was hired as a computer. Her achievements include the discovery of variable stars and nebulae, including the Horsehead Nebula. Henrietta Swan Levitt joined the team in 1902, where she had a long career at the observatory, and her discoveries include tons of variable stars, work in period luminosity relationship, which became known as Levitt's law, and she developed the first standard candle used in astronomy. So as I mentioned, the Harvard computers worked on glass plate photographs. So in the late 1880s, astrophotography was still relatively new. And so originally, they would use daguerreotypes, but then moved on to these glass plate photographs. That's how the observatory would capture the night sky. And so an example of a glass plate photograph is shown here. This one was taken later in 1945. But the computers studied the glass plates. They're, kind of about this big. And they would compare different images of the same star, often by overlaying the plates, to determine how stars changed over time. And many variable stars were discovered this way. So here's another example of a glass plate. This one was taken in Cambridge much earlier. And on the right is the plate, and on the left is the plate jacket that is used to store the plate. And so this plate is actually one of the more famous plates, I guess, because Williamina Fleming used it to discover the Horsehead Nebula. So on the left here, you'll see the original glass plate storage area, when the observatory was first getting into using glass plates. And on the right is the current glass plate storage, also called the plate stacks, where researchers still continue to use the plates. And so here's an image of Annie Jump Cannon working on a glass plate. Annie Jump Cannon is probably, the most well-known of the Harvard computers. She would go on to be named the curator of astronomical photography. She would be given an official title of astronomer from Harvard. She received an honorary PhD from Oxford University. She developed a way to classify stars that we still use today. So her work in astronomy, as with all the other women, was really instrumental and really impactful. And so the glass plates are actually currently being digitized in a project called DASH, which we'll reference later. So those will, be digitized, and many of them are online currently, being used by, researchers and such. However, at this time, I'm going to talk a bit about a different digitization project called Project PHaEDRA. PHaEDRA stands for Preserving Harvard's Early Data Research in Astronomy. It's an initiative between the Woolbach Library and many other partners to digitize and transcribe over 2,500 notebooks created by the Harvard computers. And so on the bottom there is our website with more information about Project PHaEDRA. So as I mentioned earlier, the computers did a significant amount of calculations in notebooks, often working with a partner who would read off what they were seeing on the glass plate. And so these early notebooks produced, in the late 19th to early 20th centuries, really represent the early history of the Harvard College Observatory, and they're important primary source documents that show the evolution of observation methods and the history of astronomy. So here you'll see examples of the notebooks that make up PHaEDRA. In 2016, the notebooks were placed in the care of the Woolbach Library. The notebooks have all been scanned and digitized as of now. All members of the public can view the digitized notebooks by going to our library website and viewing our finding aid. And you'll also see, you'll see the link there at the bottom of the screen. And so this is just an example of, the PDF of the Project PHaEDRA notebook, of one of the notebooks, and kind of how you can scroll through and view the notebooks from home. So of course, there are other ways to engage with the notebooks other than, the finding aid on our website. Today, I'll be introducing to you one of our projects, the project on the Zooniverse platform, but there are other branches of Project PHaEDRA. For example, full text transcriptions of the notebooks are being done by the volunteers on the Smithsonian Transcription Center. We also have educational materials for teachers on the Smithsonian Learning Lab, where we connect the primary source notebooks with other resources about the computers and women's history. So I'll be focusing today on getting started with our Zooniverse project. Zooniverse.org is a citizen science platform with just, a plethora of really amazing projects on a wide range of topics. We're really lucky to be able to host our project on this platform because there's already a great community of volunteers who are interested in doing citizen science on this platform. So our project is called Star Notes, and with this project, we're asking citizen scientists to go through the Project PHaEDRA notebooks looking for glass plate numbers. So when the computers were working on these plates, they would write down the plate identification number in the notebooks when they were doing their calculations so that they would know which photographs they were working on. So each plate has a number associated with it, and the computers would write down that number when they were working in these notebooks. So with this project, with Star Notes, our volunteers are finding and tagging those plate numbers written in the notebooks. So Star Notes is run by myself and my colleague, Nico Carver. Nico Carver is in the right on this image, and he is the librarian for collaborative programs at Woolbach. So why is this project being done? By tagging the plate numbers in the notebooks, the eventual goal is to be able to directly connect the plates mentioned in the notebooks with the plates that are being digitized. You know, as I briefly mentioned, there's a project called Dash that's working to scan the plates. So we'll be able to connect the glass plates with the PHaEDRA notebooks. This will really enrich the metadata of the notebooks and allow future researchers to learn more about the history of astronomy and the history of our universe. We also just really want to highlight the impact that these women had on the field of astronomy, you know, and really give them that recognition that they deserve. And lastly, we've been really lucky to be able to create a community around these primary source documents and work with citizen scientists to, you know, really work on this history and work on this project. And so we're really lucky for that. So I'm going to take you all through the project a bit to explain kind of how the different pieces work on the website, and to explain how people can get involved with the project. So if you're totally new to Zooniverse, you'll want to first register. So you can, our project link is at the top there, zooniverse.org/project/PHaEDRA/StarNotes. So the registration process, if you look in the upper right hand corner of the page when you're, you know, on the Zooniverse website, you'll see a box that says register, as you'll see on the left here. It's outlined in blue. So you can register for a new Zooniverse account if you don't have one. You can contribute to the project without registering for an account, but you know, it's free and you can really keep track of your progress that way. And, you know, post on the discussion boards and stuff like that. So the registration, it'll take you through the registration, picking a username, password, you know, putting in your email address and your name for any scientific papers and that sort of thing. So once you've registered and it's the first time you've been on our project, you'll be taken through the tutorial. So the tutorial will you know, pop up first time you go on our project. And it'll take you through how to identify plate numbers. So there's a lot of calculations in these notebooks. There's a lot of numbers. And so the tutorial will kind of explain what we're looking for and how to really find those plate numbers. But you can go back to the tutorial anytime. It doesn't pop up, it only pops up that first time, but then you can go back anytime throughout the project by clicking on the tab on the right when you're classifying, as indicated, you know, in this image. You can just switch over there and view those instructions again. So once you've been through the tutorial, you're free to start looking for plate numbers. And you'll do that by clicking on the classify button when you're on our project. And so that'll take you to this feature, which is a notebook page on the left of your screen. And so you'll be able to use the drag feature to click and drag a box around the plate number when you find it. So for example, on this page, we see AC1532, which is a plate number, and below that AC1586. And so once you've clicked and dragged identifying plate number, this little box on the bottom will pop up, and you'll be asked to transcribe the plate number. And that's really important because that gives us the data that we need for this project. Let's see. So if you have a question while you're going through these notebooks, that's totally understandable because it can be really tricky to kind of, tell what's a plate number and what's not. So we have some tools built into the project that will hopefully help with that. The first one is the field guide. It can be kind of hard to see, kind of easy to miss at first, but it's on the right-hand side, and it's like a little tab that says field guide. And so when you click on that, the entire field guide pops out, as you can see on the right, and it has a list of specific examples of, what might come up as you're going through the notebooks. And so that field guide is on every single page on our project. You can view it anytime and go back to it as much as you'd like. And we've updated that many times as the project goes on, as we find, kind of quirky things that have come up in the notebooks that we felt we really needed to add to the field guide. So if you have a question that wasn't answered in the field guide, we have another tool called need some help with this task. And so that's on the bottom when you're classifying, as you'll see highlighted in orange there. So you can click that and something will pop up and give you some more tools and some more, research opportunities to perhaps help you with your classifying. Just some more tools for our volunteers. And there are definitely times when something comes up and it's not in the field guide or not in the help feature, and that's totally fine. It happens all the time. If you're uncertain about a page, you can definitely take your best guess and then click the done or done and talk feature after you've drawn your boxes. The done feature will take you to the next page, and the done and talk will actually take you to the talk board feature, which is the kind of message board feature on our project and on all projects on the Zooniverse platform. So the talk feature you can access anytime. It's at the top of our project on the right there, as indicated on the screen. But volunteers can use the talk feature to ask questions, point out interesting things, or connect with other volunteers. We have a section where you can introduce yourself, and so a lot of folks will just say hi, say why they were drawn to this project. And so this is a great tool. Lots of folks use the talk feature to point out interesting things or ask questions. I frequently check the talk boards and try to answer questions, but there are also other volunteers who are really, really great at answering questions. So it's really a great community that's, been built into this project. And so if you do click done and talk instead of just going to the next page, and you have a question, you want to ask it, right? By clicking done and talk, it'll take you to this page, and you can leave a note about the page that you're working on. You can ask questions in that field on the bottom there, use a tag, anything you'd like, add your comment, and it'll be added to the talk boards. So after the plates are found, the data is given to us in the format of these CSV files. And then my colleague, Nico, uses a Python script to clean and aggregate the data. On the right, you'll see an example of the data. 7 volunteers look at every single page. And that's because we really want to take an average of their responses. We understand that the handwriting can be very difficult and can be hard to read in these notebooks. So we really want to get the best answer possible. It's easy to make a mistake. It's totally understandable. And so, we really use this Python script and use this data to get the best answer possible from our volunteers. So other than engaging on with our volunteers on the talk boards, we also connect with our volunteers in some other ways. I work with, folks who want to get credit for their volunteer hours. So, a lot of students, especially in the pandemic, have had a hard time getting volunteer hours, virtual volunteer hours. So we work with students to give them that credit for, the citizen science that they're doing, whether that's credit for school or kind of whatever, they need. We also have monthly virtual office hours, where we get to see some of our, volunteers face to face, and they can ask us questions. And so that's been really nice to, connect with that community and, answer those questions. Our next office hours is on Tuesday, May 11th at 2 p.m. Eastern Standard Time. Every office hour, we have a brief presentation at the beginning. And in May, we'll be hearing from Air and Space historian, Dr. Emily A. Margolis. And so lastly, before we wrap up, I'm just going to kind of show you some examples of interesting things that folks have identified in the notebook pages, and some examples of what you might see as you're looking through these pages, other than just, calculations. So on this page, charts and graphs are, come up frequently, as you'll see on the left. On the right is really interesting because they're spectra lines. And so the computers did a lot of work with identifying spectra. And so here on the left, you'll see actually Annie Jumpkinnon's signature, which is really, really cool, in one of her notebooks. On the right, you'll see an example of a star chart, which the astronomers would frequently draw what they were seeing on the plates. And so you'll see that those examples come up a lot as they're trying to, work through what they're seeing on these glass photographs. And lastly, we have another example of what a calculation page might look like on the left, talking about plates, variables, different stars, that sort of thing. And on the right, this is kind of a rare image, actually. It's, a photograph of the Large Magellanic Cloud. So it's really neat to see those photographs pop in there every once in a while. Sometimes they get inserted in the notebooks later on in time. So how's the project going so far? How's StarNotes? What's the progress of StarNotes like? Thanks to our awesome volunteers, we've completed the notebooks of Williamina Fleming, Henrietta Swan Levitt, Dorrit Hofflet, Adelaide Ames, Evelyn Leyland, Henrietta Swope, and Sarah Breslin. So they've gone through all of their notebooks, dozens and dozens of notebooks for those particular astronomers, and identified all the plates in those. We still have lots of astronomers to go, but thankfully, we have many volunteers. We have over 7,000 volunteers who are working on our project, and we're really grateful to them for their work. So that brings me to the end of this introduction, and we'd just like to say thank you to everyone who has volunteered with this project so far, and everyone who might volunteer in the future. Thank you so much.